closing of your eyes, blocking of the sound. Look, no, I can't keep up with it. It's a good thing I don't have to keep up with it. Because, you know, on Tuesday, just from having one day off, I forgot my glasses. So, I mean, you know, I had to keep up with it. I'd be in sad shape. We're going to find that in this area where we have what we see as parts of the medulla oblongata, we're going to see that we've got the parts of the midbrain, we've got these parts. They're going to have nuclei, nucleus, okay, meaning body, dendrites, of something called reticular formation. Have you ever heard of that? Yes, no, maybe?
No.
Okay. Well, now, from part 1, we learned the body has those 3 types of fibers: collagen, elastic, reticular. And reticular is just trying to give us like a example of what it might look like. Okay? So, reticular formation in this case now, as we look at it in relationship to the brain, it means it looks like this branching that can occur from that area of the brain and reach other areas. All right? So it's like a branching from that part of the brain that looks like it can go to other areas. We have learned that this structure has a cardiac center, meaning it will affect the heart, a vasomotor center, organs, and a respiratory, lungs. So this reticular formation, luckily, where we're looking at it, is monitoring a lot of what is taking place that we are not having to be consciously aware of. It's receiving information, for example, about my respiration rate. As I'm walking through the class and trying to move and do that sort of stuff, it notices my respiration is up a little bit. And it tries to help the body meet that demand. As we continue with the structures, see this area that they're trying to represent as the bulge? Okay? Pons. When you look at pictures in your textbook, and your lab manual, I think both, have some really good pictures of the pons. Your textbook is going to talk quite a bit about the structure of the pons. It's going to tell you about these thick stalks. It's going to tell you about all these little pieces to it. We don't have time to learn that much, okay? You're going into the area of neurology. You'll learn it, okay? So for our purposes, I want you to know what that area does, okay? So the stalks that it talks about having, we get to connect our cerebellum to the pons and the midbrain. So if you're looking at the brain, which it's not really represented on this, okay, but you'll see it in the pictures. But if I have that structure that it's trying to show me, okay, it's letting me know I have a connection to my cerebellum into my midbrain. Okay? So, we find that it also has nuclei of that particular formation, but we also find that we have tracts of the white matter because it's giving me some connection to another area of the brain. Okay? And we do that by tracts, axons. Okay? All right. Fascicles, if you remember, bundle of fibers. In this case, a bundle of the axons. All right, is everybody with me on that? Fascicles cross between the left and the right sides of the brain. Longitudinal, okay, will carry sensory information up, motor down. So sensory information will get to continue up, motor will get to continue down. In sensory information, this area is important for sensory information of hearing, equilibrium, taste, facial sensations of touch and pain. Because this area is going to now be connected to a cranial nerve. This area is inside the skull. It does not meet spinal nerves that exit. Does that make sense? So this area meets cranial nerves. Cranial nerves will get to pick up sensory information here.
So when you're saying that area, you're talking about like the whole of the midbrain and hindbrain?
As you begin to look, all right, so take a peek. Take your half, all right, and do you guys see how if you begin to look right here where that bulge might be, you begin to see some Roman numerals? Looks like a little spot right there, a little spot right here, a little spot right there. It begins to look like, as you go down the side, right down through the sides here, like all these little areas that look like little things coming off of the bulge, okay? Got all these little things coming off the bulge, and they're continuing into a little bit of that area of the medulla, okay? But a lot you see around that bulge and everything, they've got Roman numerals. Those are going to be your cranial nerves. Because as we continue down the spinal cord, what we meet are the spinal nerves, which is my peripheral nervous system. My cranial nerves are going to be here. Okay? So, if I'm at that area of the brain, sensory information, because up to this point, looking at those spinal nerves, we've only talked about the stuff such as pain, pressure, touch, that sort of thing. I'm now picking up some different senses. For example, hearing. Remember how I said we have like the special senses? Okay? Sight, smell, taste, hearing, general, but they added equilibrium because equilibrium is part of the inner ear. So I'm now picking up my special senses. Yes, no, maybe? All right. In motor information, we'll see it can affect eye movement, facial expressions, chewing, swallowing, urination, secretion of saliva, and tears. You're going, whoa, hold up. Why is urination in that bunch? Last time I checked, that one up here. Right? Right. Okay? You're going to find that in those Roman numerals of those cranial nerves, we get one very interesting nerve called the vagus nerve. And I don't mean like a hunk of burning love with Elvis. All right? We're talking VAGUS. Ever heard of like they had a vagal response? That's because that nerve, the vagus nerve, but y'all do know that meant I really like Elvis and Vegas and everything, right? And when I told my husband I wanted to go to Vegas and be married by Elvis, he wouldn't let me. But anyway, I told him on our 5th anniversary that's where we were going. So, and that we were going to renew our vows with Elvis in Vegas. And I meant the real Elvis. Anyway, okay, so that particular cranial nerve, it gets to run the entire length of our body and hit every organ. So any type of pressure or any type of sensation to the vagal nerve can have that effect on all organs of the body. It's the reason that Elvis died.
Is it because he died on the toilet?
He died on the toilet because he was straining to go to the bathroom and he was hitting the vagal nerve, and he cut off the sensations of the vagal nerve, which supplies the heart and respiration, which stopped the heart and respiration, and he died. Vagus nerve is fun. Happens to Vegas taking it's fun. Okay? So that nerve, even though cranial, that nerve gets to affect all organs of the body, which is pretty interesting. So that's why urination is here, because of how it goes the entire length. In this part of the brain, with that reticular formation, this time we're learning that those nuclei in the pons, they can affect our sleep, our respiration, and our posture. So this area, okay, these parts of that brain stem, all right, we're beginning to see that they're having effects on a lot of things we don't have control over, okay? A lot of the things that are autonomic. The midbrain, so if you begin to look, all right, moving upward, okay, the midbrain going to connect hindbrain to forebrain, okay, forebrain, hindbrain. Once again, your textbook and so forth, going to get into great detail about the structure, okay? Once again, we don't have that much time, okay? So, we're going to